Hello guys, in today's video I'm going to explain to you the Laplace transform, a very important concept in engineering and also in math. So, the Laplace transform allows you to transform a function from a variable t, which usually represents time, to the Laplace domain, which is represented by the letter s, and it is also known as the frequency domain. Of course, here you can have other types of variables. You can have x, for example, but in engineering it is usually used t because it represents time. So, the Laplace transform is an integral transform, which has the following form. So, f of s is equal to the Laplace transform of a function in the time domain f of t, and this is equal to the improper integral from 0 to infinity of e to the minus st times the function times dt. Calculate the Laplace transform of 1. So this will be the improper integral from 0 to infinity of e to the minus st times 1 dt, and this is equal to, here, as it is an improper integral, we have to change the limits and apply a limit. So here would be 0 to r e to the minus st dt. This is equal to e to the minus st over minus s from 0 to r. So the limit when r tends to infinity of this e to the minus st over minus s evaluated from 0 to r is equal to, so first we solve this part, so this will be, alright, so again limit r when r tends to infinity, so e to the minus s r over minus s, here will be minus, but we have a minus, so plus e minus s0 over s. So here we have to apply the limit. So the limit when r tends to infinity of e to the minus s r over minus s, this will be equal to 0, as we can rewrite this like 1 over e to the sr here minus s. So this exponential will grow and grow, as here it will be a very big number. In r will take a very big number, so this will be 0. 1 over a big number is always 0. So now we evaluate the second function, the second fraction. So any number elevated to the 0 power is equal to 1, so this will be 1 over s. So this is 0, the final answer will be 1 over s. Now, all the steps that I have taken to solve the integral, someone has made it for all the general cases of the Laplace transform, so, and has put them in what we call Laplace tables. So from now on we won't be solving Laplace transforms with the integral, but we will be using the formulas that are found in Laplace tables. So feel free to search this in Google and take a look to these tables so that you get familiarized with them. Alright, so we have solved our first transform, and we know that the Laplace transform of 1 is equal to 1 over s. And the Laplace tables tell us that the Laplace transform of any constant a will be equal to a over s. So a can take any value. For example, a can take the value of 1 and will be equal to the Laplace transform of 1 is equal to 1 over s. A can be 34, and the Laplace transform of 34 will be equal to 34 over s. Now I'm going to explain to you the linearity of the Laplace transform, which is very important. So if we have Laplace transform of a function f of t multiplied by a constant, the result of this will be equal to the constant multiplied by the Laplace transform. And if we have the Laplace transform of a sum of functions f of 1 plus f2 of t, each one multiplied by its own constant a and b, this will be equal to the Laplace transform of the first function multiplied by constant a plus the Laplace transform of the second function multiplied by its constant b. Don't worry, we will check this with an examples. Now let's review the Laplace transform of a function t. According to the Laplace tables, this is equal to 1 over s squared. So for example, the Laplace transform of 3 times t will be equal to, according to our linearity properties, 3 times the Laplace transform. So 3 times 1 over s squared is equal to 3 over s squared. Now let's check the Laplace transform of a variable t to the power of any number n. So this will be equal to factorial n over s plus, to the power of n plus 1. So for example, if we have the Laplace transform of t cubed, this will be equal to 3 factorial over s to the power of 4, 3 plus 1. So this will be equal to 3 times 2 times 1, 6 over s to the power of 4. Note that we can obtain the Laplace transform of the function t with the formula that we have just reviewed. So let's do it. So the Laplace transform of t, this will be equal to the power of 1 is equal to 1 factorial over s squared. So this will be equal to 1 factorial is 1 over s squared, which is the same one as this one. I recommend you that you learn the Laplace transform of t and the Laplace transform of a constant because they are very common to see them in differential equations. And whenever you have a function that has t to the power of greater than 2 or equal to 2, use the formula that we have just seen. Now let's review the Laplace transform of a function exponential to a constant a times t. This will be equal to 1 over s minus a. So let's do an example. The Laplace transform of e to the power of 3t will be equal to 1 over s minus 3. A is equal to 3. And for example, the Laplace transform of e to the minus 3t will be equal to 1 over s minus 3 will be equal to plus 3. Now the Laplace transform of a function sine of a constant a times t will be equal to a over s squared plus a squared. So let's do an example. The Laplace transform of sine of 4t will be equal to a will be equal to 4, so 4 over s squared plus 4 squared will be equal to 16. The Laplace transform, for example, of sine of minus 4t will be equal to minus 4 over s squared plus, here we have to put in the minus 4, but minus 4 in parentheses squared will be equal to plus 16. Now let's continue with the Laplace transform of a function cosine of a constant a times t. This will be equal to s over s squared plus a squared. So let's do an example. Laplace transform of cosine of 5t will be equal to s over s squared plus 5 squared, 25. The Laplace transform of cosine of minus 5t will be equal to s over s squared plus minus 5 squared in parentheses will be 25. Now let's continue with the Laplace transform of an exponential to the power of a t multiplied by a function f of t. This will be equal to the Laplace transform of the function evaluated in s minus a. So, for example, if we have the Laplace transform of a function e to the power of 3t times t squared, so this would be equal to, first of all, we have to calculate the Laplace transform of t squared. So the Laplace transform of t squared will be equal to 2 factorial over s to the power of 2 plus 1. This will be equal to 2 over s squared, s to the power of 3. Then we have to evaluate this function in s minus a. So this will be equal to 2 over, and wherever you see an s, you evaluate s on s minus a. So here a will be equal to 3. So s minus 3 cubed. This will be the final answer. Let's do another example just to make things a little bit more clear. So if you have the Laplace transform, for example, of a function e to the power of, let's say, 5t. Sorry for my 5 here, 5t multiplied by a cosine of 3t. So this will be equal to, first of all, we have to calculate the function of f of t. So f of t, the Laplace transform will be equal to f of s, and this will be equal to s over s squared plus 9. So we have now f of s. Now we have to evaluate on f. We have to evaluate f on s minus a. So we know a is equal to 5. So whenever you see an s, you put in s minus 5. So s minus 5 over s minus 5 squared plus 9. And this will be the final answer. Now let's review the Laplace transform of the derivative of a function, the first derivative. So this will be equal to s times y of s minus the initial condition of the differential equation. So, for example, if you have 2y first derivative plus y is equal to 3, and you have to pass this to the Laplace domain, then you will apply the Laplace transform to both sides. Equal to the Laplace transform of 3. And you have to apply the formulas that we have already seen. So we have that this is a sum of functions, then we know that the Laplace transform of a sum of functions is equal to their individual transforms. And now we apply the formulas. So first of all, we have to get the Laplace transform of 2 and the 2 times the first derivative of y. So this will be 2 times the Laplace transform of the derivative of y is s y of s minus the initial condition. So the initial condition is given in the problem, so here let's say is equal to 1, so minus 1. Then plus the Laplace transform of a function, which is the Laplace transform. Here we don't have any derivative, so it is just the Laplace transform. And this is equal to the Laplace transform of 3. And if you remember, the Laplace transform of a constant is equal to the constant over s. And now we just have to simplify this. It will be equal to 2s y of s minus 2 plus y of s equals 3 over s. Now let's review the Laplace transform of the second derivative of a function y. This will be equal to s squared times the Laplace transform of y, which is y of s, minus s times the initial condition minus the initial condition of the first derivative. So let's do an example. For example, 3 times the second derivative of y plus y is equal to e to the power of 3t times sine of t. So we apply the Laplace transform to both sides of the equation. And now we start using the formulas. So here we have a second derivative, so this will be equal to 3 times s squared y of s minus, sorry, the initial conditions I didn't set them, so let's say that the initial condition of the first derivative is equal to 2 and the first condition of the function is equal to, let's say, 4. So here again we have to convert this second derivative to the Laplace transform, so s squared times y of s minus s times the initial condition of the function, which is 4, minus the initial condition of the first derivative, which is 2. Now let's calculate the Laplace transform of y, which is just plus y of s, and this will be equal to, here we have already seen this is an exponential multiplying a function, so first we have to calculate the function and then evaluate it on the function on s minus the constant a, which is 3. So first we calculate the Laplace transform of the function, which is, here we have a as 1, so 1 over s squared minus 1 squared, sorry, plus 1 squared, which is just 1. And now we have to evaluate this on f of s minus a, which is f of s minus 3. So this will be equal to 1 over, here we see an s, so s minus 3 squared plus 1. And we just simplify this side of the equation, which is 3s squared y of s minus 4s, sorry, minus 4s times 3 will be 12s minus 6, and this is, I'm sorry, plus y of s, and this is equal to 1 over s minus 3 squared plus 1. Thank you so much for watching my video. Please let me know in the comments if you like it and if you learn something from this. Please consider liking this video and subscribing to the channel. I would really appreciate it. Take care and good luck.